you're actually going to go to your actual homeroom after this class. So homeroom's going to be from 9:20 to 9:45, and you're actually going to be registering for your classes. So in the years past, we went to a computer lab to do that. Now you have your MacBook, so we're doing it right in class, okay? So that is our schedule for today. It looks like, so second hour will end like 10 minutes later. Third hour will end 5 minutes later. And so our whole, this must be our homeroom schedule here. Yes.
Are our lunches at like the regular time?
Lunches.
Yeah, lunches will be at the same time. The only difference will be is if you had some of you have a 12:05 lunch, like if you have, I think Ms. Pooler, I think Mr. Larson, there's a handful that have it 12:05. They're just going to come down and see the attendance station. So it's only going to affect the first couple classes. Everybody else is on their same schedule for lunch.
Okay, perfect. All right. Did you ever pass Okay, so we are going to start the quadratic formula today. And to get started, let me just get my notes up here. So in the past, when I would get students from the middle school for quadratic formula, they learned the quadratic formula to the tune of Pop Goes the Weasel. And that's how they remembered it. And I can't sing to save my life. My family will not allow me to sing. I am horrible. In fact, my sister, I promise you, is the only person in the world that sings worse than I do. We actually have contests, like on holidays. Our kids try to see who's worse, but she's worse than me, but that's it. No one else is. So what I'm going to do is show you just the Pop Goes the Weasel. And as I was doing this yesterday, trying to find different videos, they're all over. Like, teachers must assign to students to come up with a tune to to the quadratic formula and have kids do it, because it was like all over YouTube. So I'm going to show you the Pop Goes the Weasel, so you just get that tune. And then Lady Gaga has a song. There's also ones on, like, there's raps for it. There's a One Direction song. But I'll just show you these two really quick.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
So that is what, we had a teacher in the middle school who's no longer there now, Mrs. Doubt. Yeah, she used to have a good voice and she would sing this with them, but unfortunately I can't do that.
The most important thing in the Equinox isn't any of the advanced safety features we've put into it. It's what you put into it. Chevy Safety standard on
Hold on 1 second.
2021 Chevy.
Negative b plus or minus root of b plus minus 30 all over 2a. Negative b plus or minus root of b plus minus 30 all over 2a.
All right, so I was thinking we should make Mr. Ostad come back someday with his own little tune. What do you think about that? Yeah.
I might be in the running with your sister.
But I think it's still going.
Is it? Oh,
Sorry. I mean, you can leave it on if you like.
Okay, so today what we're going to talk about is an additional way to solve quadratic equations. Okay, so this kind of shows you everything we've done throughout this chapter. So first of all, we're always dealing with quadratic equations, which means that they have an x squared in them. And the very first thing we did is we graphed them. And if you remember, we graph parabolas. We look at where did they cross the x-axis, okay? And graphing can be used. You can use graph paper and do it as long as your graph crosses the x-axis at an actual point that you can tell. Like if it's right at -1 and +2, you can tell those answers. However, there are times where it might cross at 1.2573, going on forever in a decimal, and our graphing calculators tell us what those results are, but it wouldn't work just on graph paper, okay? Then we learned how to factor, and with factoring, we could tell where we could solve for x. We did that last week. But the problem is not every equation can be factored, okay? We also did kind of like a day with the square root property. We did it more with complex numbers, but we'd get down to like x squared equals 64. And then you'd know that you would take the square root and x would equal ±8. So we didn't spend a whole day on that, but that's what they mean by square root property. Completing the square we did yesterday, and quadratic formula we are going to do today. That works on every single quadratic formula, or I'm sorry, equation, quadratic equation. Doesn't matter if it can be factored, you still can use either of these two. If it crosses at the x-axis at whole numbers, you still can use these two, okay? And then always know too that you can plug your equation into your graphing calculator and see where they cross the x-axis to be able to check if you're doing it correctly, okay? But these two right here work on every single equation. And then a lot of times what kids do is they choose one of the two that they like better, and they use that one, okay? So let's go here. So again, this is the quadratic formula. Depending on how far you got in your Algebra 1 class, I'm guessing you all have seen this before. Am I correct? Have you guys all seen this? Okay. So here's how we do the quadratic formula. First thing, you'll always have to get everything to the left side of the equation. So the first thing I'd want to do is bring this 11 over. So I'd get x squared minus 10x. And when I bring that 11 over, it would change signs, so it'd be -11. Okay? Then what I would do, a is what's in front of x squared. So that's 1. So a is just the number in front of your x squared. B is what's in front of your x, including the sign, so it's -10. And C is your constant, including the sign, so it's -11. Okay? Then we are going to substitute those into the quadratic equation. So we get x equals -b would be minus a -10, which you could do in your head at that time and just write as a +10, plus or minus b squared is -10 squared minus 4 times a, which is 1, times c, which is -11, all over 2 times a, which is 1. So if you look at this, if you can factor something, it's less work. But still, you're okay if you ever couldn't factor something, you could always try this and get your answers that way too, okay? Now, here's what I do. I punch in what is underneath my square root, just how it looks on my calculator. So do you guys have your calculators out? So we are going to take this and punch it in exactly how it looks. All right. So if we go ahead and take that, what's underneath the square root here, and I would just type it exactly how it looks. So do your parenthesis, -10 parenthesis, and then that was squared, so you can just hit x squared. Then we have -4 parenthesis 1, which we really wouldn't have even had to type that in. And then the last thing we're multiplying by is a -11. Parenthesis, enter. Did you guys get 144? So I always type in what's underneath my square root. So now what I get here, minus a -10 is 10. We just got this to be 144, and that is over 2 times 1, which is 2. Now, what is the square root of 144? 12. Good. So now what we would have is 10 plus or minus 12 divided by 2. So what we have here now is we can take that and actually find the numbers that we would have. So I'm going to break this up into 2. First, I'm going to do 10 plus 12 divided by 2. And then I'm going to do 10 minus 12 divided by 2. 10 plus 12 is 22. Divided by 2 is 11. 10 minus 12 is a -2, divided by 2 is -1. Now today, when you get a whole number like that for your answer, what that means is we could have factored it. Usually if it's not able to be factored, we would not get whole numbers, okay? All right, so let's go to our second one then. Now this one, yes, one.
So would that work all the time? Like with 144 can be square rooted, but would that happen every time?
No, good question. There's times today that we'll get like -6, and you, with a negative, you know you bring an I out, and 6 you can't take the square root of. So then we have to leave that 6 under the square root and simplify it. And I'll show you something like that. Another thing that will happen is you might get under your square root like 27. And what 27 is not a perfect square. But then you have to ask yourself, is there a perfect square that goes into 27? Is there?
Yeah.
What does?
No.
So then what we would do is take the square root of 9 and bring that 3 out, and we would simplify it that way, which is going to happen the majority of the time. Most of the time, we will not get whole numbers. Okay, good question. All right, so let's go here, and right away, what we're going to do, this one already is in the proper form, where it's x squared x, and then my constant. So my a is 1, my b is a -16, my c is 64. Okay, so what I'm going to do is substitute in there, So I get minus b is a negative 16 plus or minus b squared is a negative 16 squared minus 4. Then we're going to put a in, which again is 1. C in this case is 64. All over 2 times a, which is 2 times 1. Okay, now on these, like when you turn in your homework, like from what I taught yesterday with the completing the square, you have to show your work. Same here. Make sure you don't, I mean, you might skip a step. You might, you know, do this as you're doing it, not put minus a negative 16. You might multiply this as you're doing it, but I need to see steps. I need to see some work so that I know that you're doing it. So negative minus 16 is 16. Now let's go and punch this into our calculators, okay? So if we do that, and remember, you want to type it in exactly how you have it there. So we are going to do parenthesis, negative 16 parenthesis, then our x squared, and then it's minus 4 times 1, you don't really even have to put in, times 64. Or I could have put that, oops, or I could have put that 64 in parentheses too. Okay, enter. Did you guys get 0? Okay, so when we come back, this is 0 now, over 2 times 1 is 2. Okay, so what you're going to have there is 16 plus or minus 0. Is that going to change anything? No. And then over 2, so that means our answer is 8. So again, here's one where we have a whole number. This would be super easy to check on your calculator. You could go and type this in and make sure it crosses at 8. And so if you looked at your graphing calculator, say this is x is 8 here, would this one open up or down? Up because it's positive, right? So at x equals 8, we would have a parabola opening up. Okay. All right. So now we're going to look at ones that would not have been able to be factored, and what does that look like? Okay. Again, this is in the correct form. So a is what's in front of our x squared, that's 2. B is 6. C is negative 7. And then we're going to go ahead and just substitute in. So x is negative b is minus 6 plus or minus the square root of b squared is 6 squared minus 4. A is 2 and c is negative 7. All over 2 times a, which is 2 times 2. Okay? Again, let's go ahead and type what's under our square root into our calculators. Okay? So what I have there is 6 squared minus 4 times 2 times a negative 7. And did you guys get 92? Okay, so that is what's under our square root. And that is all over 2 times 2, which is 4. So this goes back to Gavin's question. You are not always going to get something that ends up being where I can take the square root of this. However, when I do get something like 92, I have to think, is there a perfect square that goes in there? Is there a perfect square that goes into 92? I didn't put this on yours, but what do you guys think? Does 4 go into 92? Yeah, how many times?
23.
23. So what we would do then is write this as -6 plus or minus the square root of 92. We can write as 4 times 23 all over 4. And what do you do with that 4 then that's under the square root?
Put 2 on the other side.
Yes, you take the square root of 4, which is 2, and you put that inside there. Now what I have is this. I have -6 plus or minus 2 times root 23 all over 4. And here is a place that you have to look at. Could I simplify this more? And how you know that is you look at this fraction, 6 over 4, and you think, could I reduce that? And then you look at this number over 4, and could I reduce that? And typically what I do, if I can reduce both of them, then I take it another step and I do that. So can I reduce 6 over 4? Can I reduce 2 over 4?
Yeah.
Yes. So what you would do then is rewrite this as -6 over 4 plus or minus 2 times root 23 over 4. And I'm going to reduce each of those fractions. What is -6 over 4 reduced down to? -3 over 2, good. And 2 over 4 reduces down to 1/2. So on top, this 2 becomes a 1, so I just have root 23 over, and then that 4 becomes a 2. Now, I would accept the answer. We talked about this a little bit yesterday. I would accept this answer, but when they're over the same denominator, the book will always put it back together as one fraction, where they just write what's on the top over the common denominator 2. So I really would accept both of those. This is the more proper way to write it. Okay. So now this one here, if you look, we do not have that in the right form. So what I have to do is bring this -10 over to the left-hand side. And what I would get is x squared minus 6x. And when I bring that -10 over, it's going to become a positive 10. Okay. Now what I look at is my a is what's in front of the x squared, which is 1. My x is what's in front of the x, -6. C is 10. And then I'm ready to substitute into my quadratic formula. So I have -b is going to be minus a -6. And b squared is -6 squared minus 4. A is 1, C is 10. And that is all over 2 times A, which is 1. Okay, now we're going to go and type this in. So we have parentheses, -6 parentheses x squared, and then it's minus 4 times 1, which we don't really have to do, times 10. And did you guys get a -4? Okay. So here's what we have then. Minus a -6, those negatives cancel out. So you would just get 6 plus or minus, we got this to be a -4 all over 2. What do we do with that negative? So what would we bring out? We'd bring out the I, and then this is gone, okay? Also, what is the square root of 4? 2. So we could just get rid of that square root and just write it as 2i all over 2. Now again, I would look at, can I simplify this? Can I simplify 6 over 2? And can I simplify 2 over 2? I can, right? So here, we are going to write this as 6 over 2 plus or minus 2i over 2, and we're going to reduce each of those. 6 over 2 becomes 3, and here my 2's cancel, and I have I. So if you guys wanted to check this one on your calculator, is this one going to touch the x-axis? No. Remember, whenever there's an I in it, if you looked at this graph, it has a positive x squared, so it's going to open up. It's going to be somewhere up here. It is not going to touch the x-axis, so these are imaginary solutions. Okay? All right, so let's go to this. Let me just see what this one looks like and see if it's different. Okay, let's go ahead and do this one. A is 3, B is 5, C is 4. So if I go to substitute in, I'm going to get -5 plus or minus b squared is 5 squared minus 4 times a is 3 and c is 4. All over 2 times a, which is 2 times 3. Okay. So again, I am going to punch what's underneath that square root into my calculator. So if I get that up, it would be 5 squared minus 4 times 3 times 4. Do you guys get a -23? Make sure our masks are covering our nose, okay? So we have a -23 under there, all over 2 times 3, which is 6, okay? So now what I'm going to do, -5 plus or minus, what can I do with that minus sign? Or, the minus under the square root. I'll bring out a I. And then when I'm deciding, can I take this further? Can you reduce 5 over 6? No. Can you reduce, this is really like 1 over 6. I can't reduce that either. So you would leave it just like that. Okay? All right, so the second thing that we're going to learn today is that part that's underneath the square root that we've been putting into our calculators. So it's this part right here can tell us what our solutions are going to be like. And so sometimes today what they'll ask you to do is find the discriminant. That's what's under your square root. B squared minus 4ac. And what they will ask you is to find that. And once you find it, you can tell what kind of solution you're going to have just from that value. Okay? So first we have to talk about what is the difference between a rational number and an irrational number. Rational numbers are anything that can be written as a fraction. 1 is a rational number because it can be written as 1 over 1. Any fraction is rational. Think of rational as it can be written as a ratio. Okay? Any whole number is rational. Any repeating decimal, like 0.3 repeating, what fraction is that? 1/3. If you have a square root that's going to come down to a whole number, that's rational, okay? Irrational numbers are ones that cannot be written as a fraction, okay? They're going to be decimals that go on forever and ever and ever. So like if you did the square root of 5, that is not ever going to stop. That's irrational, okay? Pi is irrational. This decimal right here would keep going and going and going. There's 3 dots here. That means it's irrational, okay? So here's what that discriminant tells us. If the discriminant is bigger than 0, which means it's positive, and what's underneath there, what you found in your discriminant, is a perfect square. So what that means is it's 4 or 9 or 16 or 25, then what that tells us is you're going to have 2 real rational roots, okay? 2 roots that can be written as a fraction. If it's positive, just like this one, but what we find in that discriminant is not a perfect square, there's still going to be real answers, but they're going to be irrational. They're going to be decimals that keep going forever, okay? If we ever get that discriminant to be 0, that means we have 1 real rational root. That graph is going to touch the x-axis in one spot, and it's going to be a real rational number, okay? And then here, what happens if it's negative, okay? If that number under there is negative, that means you have to pull an I out, so you're going to have complex roots, and that graph is never going to touch the x-axis, okay? And I didn't put this on yours, but you may want to write down, I could put this up later. You guys have a cheat sheet for this chapter that you could add this perfect squares to, or if you want to take a picture with your phone. And then I would also, if the quadratic formula is not on your cheat sheet, you might want to add that to it too, okay? All right, so let's go and do these where we're just finding the discriminant and trying to tell what our number is. So A is 7 here, B is -11, C is 5. So we're only doing what's underneath the square root, the b squared minus 4ac, which is called our discriminant. So b is a -11 squared minus 4 times a is 7 times c is 5. And then you can, on these, just go and type that into your calculator. So you are going to get -11 squared, so parenthesis -11 parenthesis x squared minus 4 times a, which is 7, and c, which is 5. Did you guys get a -19? Okay, so going back a page, if it is negative, that's this one down here. And so you would say it's 2 complex roots. So they're asking you what those roots are, what kind they are. And again, if they're complex, they don't touch the x-axis, they're imaginary numbers. Okay, so that was -19. That's one of our answers. And then we say 2 complex roots. Okay, now let's look at this one. Again, A would be 1, B is 22, C is 121. Okay, B squared would be 22 squared minus 4 times A is 1, C is 121. Okay, so if we go and type that in, we get 22 x squared minus 4, we really don't have to multiply by the 1, times 121. And did you guys get 0? So when you get 0, if you go back to that chart, when it's 0, what that means is we have one real rational root. So your graph would touch the x-axis one time. Okay? So that would be one of my answers here, and then one real rational root. Okay. If I look at this next one here, my A is going to be -5, my B is 8, my C is -1. Okay, and so B squared would be 8 squared minus 4 times A is -5, C is -1. Okay, so if I type that in, I get parentheses 8 parentheses squared minus 4, A is a -5, and C is a -1. Did you guys get a positive 44?
Yeah.
Okay. So my discriminant here is a positive 44. Now, when your discriminant is positive, that is where you have to worry about, is it rational or is it irrational? And how you tell is if that 44 is a perfect square, it's rational. If it's not a perfect square, they're irrational. Is 44 a perfect square? No. And if you ever weren't sure, take the square root of it and see if it's a whole number. And it's not. So that means it's not a perfect square. So we have two real irrational roots. Okay. All right. Then if we go to D, our A is -7. Oh, you know what? This one is not in the right order. If you look at this, you could rewrite it, put the x squared first, then the x, and then the constant. But you wouldn't really have to rewrite it. You would just have to notice that A is what's in front of your x squared. So my A is going to be 15. B is what's in front of my x, so a -7. C is my constant, so -4. Okay? And when I go to type that in to find my discriminant, it's -7 squared minus 4. A is 15, C is -4. Okay? So let's go ahead and punch that in and see what we get. So we have parentheses, -7 parentheses x squared minus 4 parentheses, 15 parentheses, and then parentheses -4. Did you guys get 289? Now, depending on how much you've done with perfect squares, do you recognize that as a perfect square? It is. It's 17 squared. But if you didn't recognize that, take the square root of 289. And if you do that, if you just go second square root 289, it's a whole number. So that means it is a square root. And I purposely put these perfect squares. Like I said, I didn't put this on your sheet and I should have. But 17 squared is 289, so that is a perfect square. Okay, so this one was a perfect square. So that is this first example. It was positive, it is a perfect square, so it's 2 real rational roots. Okay. So then if we go to our last page here, this is what your assignment is going to look like. And I don't know that we really have to go through this. I just kind of want to show you what some of your questions are going to ask you for. First, they want you to find the discriminant. Then they want you to tell the number and types of roots like we were just doing. And then they want you to use the quadratic formula and find the solutions. Do you want me to do one like that to show you?
I want to say that we already have the notes for the other ones. So I think it's just putting that together, so I think we'll be all right.
Okay, do you guys agree with that? You're good? Okay, all right, so Gavin's right. We've done where we've found the discriminant, found the number of types, and then we've done where we did the quadratic formula. It's just kind of putting everything together, okay? The last thing I wanted to show you is this. If you had -6/4 and 2/4, could you reduce both of those? Yes. This would be like -6/4 plus or minus 2√23/4. Okay. And now I can reduce. -6/4 is -3/2. 2/4 is 1/2. So I'm going to just leave that as √23. That 2 becomes a 1, so I don't have to worry about it. This 4 becomes a 2. And then really you're supposed to, once you reduce it, put it back together. So -3 plus or minus √23 all over 2. And some people will get to the point where they just reduce it without taking it apart, which if you can do that, just think, well, these 2 would become 3/2. These 2 would become 1/2 and keep it together. You can do that. What do you guys think of this bottom one? Can you reduce 6/4? Yeah. Can you reduce 5/4? So personally, I would leave this one. I wouldn't take it apart if I can't reduce both. Okay? All right, so this is that same chart that we ended with, just kind of explaining the different types of things we've done so far. And your assignment is this. Okay? So you can work on that. We do get out at 9:15 today. Yes, Devin.
Did you want to send me the homework?
The homework from yesterday?
Yep.
You can put that into Schoology.
Okay.
Okay, so we're still gonna put our assignments into Schoology, and I'll correct them from there, unless if it's like a practice quiz or a practice test that has several pages, then bring it to me that next day and I'll put it in. Questions at all?